That being said, this section 4.1 will be the subject of the first homework or the homework quiz for this chapter, just as a heads up.
What's that next class?
They're surprised, but you know, you definitely want to be able to do 4.1 in like a real good way.
By next class.
Yeah, I mean, I would recommend that.
So it's next.
All right. So what we're going to be talking about here in section 4.1 are about the inverse trig functions. So it's a little bit of a problem here, right? Because if I take, you know, a trig function like sine, this is the graph of y equals sine x. Let's actually do this. Get those grid lines out of there, right? And if I want to find its inverse, the graph of its inverse, I'll just swap the x's and y's, and I'll plot. What's the problem there with the blue, the graph in blue? It's not a function! Oh, so what are we going to do? What do we have to do to take something that's not a function, turn it into a function? We can't have a repeating x. So what we're going to do is we're going to restrict the domain from my one in red here. So if I restrict the domain from negative pi over 2 to positive pi over 2, I get that green piece then. Everybody's okay with that? Actually, I probably should have left that other piece in there. Be good to see. Right, so I have this, let's make that, change that back to red so it's easier to see the greeny. Okay, so I have this green piece in here, right? And now if I invert that green piece, or I find the inverse of the green piece, we have, oh boy, that wasn't what I wanted to do. This is what I wanted to do. I get that, which, any problem there with the piece in blue? Dark blue, I should say. No, right, that's a function. What's the problem though? Yeah, what if I wanted to solve when x was equal to, or when y was equal to this value over here? Is the blue graph going to give me that? No way, man. So that's going to be the catch, right? So we restrict the domain from our original function. That's going to give us an inverse that is a function. So we can use our calculator, design a calculator program to do that. The problem is we're going to have to be really careful about how we're deciding on our final answer. Okay? So let's look through some examples here, okay, on how we're going to go about doing this. So one possible workaround is I can just use the unit circle in reverse. Actually, before we do this, let's talk about some notation, okay? So we have these inverse trig functions, right? I have like theta is equal to sine inverse of x, and I have like theta is equal to cosine inverse of x, and theta is equal to tan inverse of x. So what is the for this function here, my domain I'm sorry. Yeah, my domain is the possible outputs for sine. So I can only take sine inverse of things between -1 and +1. And the range now, because I restricted the domain for sine when I built this, is going to be from negative pi over 2 to positive pi over 2. So when I do sine inverse on my calculator, my values for theta are going to all be between negative pi over 2 and positive pi over 2. That's the way your calculator is going to work. So those are the only angles that your calculator is going to be able to give you. The question is that going to be the angle we want in every context? And it's not always going to be the angle we want. We'll show you how to recognize that and how to work around it. Cosine inverse, similar, but the range here for cosine is going to be different. That's going to be between 0 and pi. What's the domain for tan inverse going to be? What are the possible outputs for tangent? Remember, what does the graph of tangent look like? Looks like this. Yeah, so no, the domain here is going to be all real numbers, right? Oh, that's kind of sneaky, Mr. Kulik. Maybe I should put an X. It's an element of on all these spots. And my range here for tangent notice that I use parentheses there in place of brackets. What is the difference between parentheses and brackets when we write it? Yeah, so brackets means that value is included, and the parenthesis means that it's not. Why did I use parentheses there for tangent instead of brackets? Carmen?
Because for a tan, the domain is sorry.
No, you're fine. Yeah. This is the right idea. Keep going.
It's ARN and X is not equal to n over 2 and with n being odd. So I figured it's sort of similar concept.
Yeah, so these guys are the asymptotes, right? That's where the asymptotes are. Those aren't in the domain of tangent, so obviously they can't be outputs from tangent inverse. That's why they get the parenthesis instead of the bracket. Exactly right. Carmen's dead on. Those values are not in the domain of tangent, so they can't be in the range of tangent output, or tangent inverse. Very good. That was a tricky question. Okay. So when we say a question like when I say find the exact value of sine inverse of -1/2, the answer that I'm getting needs to be in the range of sine inverse. So whatever that answer is, it needs to be between -pi over 2 and positive pi over 2. Okay? We'll talk about in a moment how I can ask a really similar question that has a very different possible answer. Everybody's okay with that? But if I have something where I just ask for the exact value of sine inverse of -1/2, That's what I'm expecting. So notice here when we say exact value, what do you suppose that we'll be able to use? Okay, we'll want an answer in terms of pi. Sure. Where are we going to get that answer in terms of pi from? The unit circle, right? If we're asking for exact values in trig class for values of angles, we're going to have to be retrieving them from the unit circle, almost assuredly, at some point, using the unit circle to get that. So let's pull up a copy of the unit circle here. I'll drop that in. And we'll take a look. All right. So what I'm going to do now is I'm going to look on my unit circle because it's sine. I'm looking for y coordinates equal to -1/2. Everybody's okay with that? So the sine part tells me it's y coordinate, and the -1/2 tells me what the coordinate is that I'm looking for. So I'm going to go through my unit circle and identify the places where the y coordinate is -1/2. Okay, found two possible answers, or two places on my unit circle. Okay. If I look at this interval, right, remember that this interval is the same thing as like an inequality. What quadrants are these covering? Okay. So if I go 0 to pi over 2 is going to be here, right? So that's going to be Q1. Everybody agree with that? But if I want the values that are -pi over 2 less than theta less than 0, that means I should be going this way and looking at quadrant 4. Do you guys agree with that? Because that's when we draw a standard position angle. So I'm looking for my answer needs to be in quadrant 3 or in quadrant 4. Let's go look at our unit circle now. Which of those two answers lies in quadrant 1 or quadrant 4? This one does, right? So that's the piece that we want. However, that's not right. Why is that not right? Yeah, very good. Right? This is not in between -pi over 2 and pi over 2. What can I do to 11 pi over 6 to get it in the right, or get it in between those? Find something coterminal to it. Very good.
Great job.
What do I have to do to get something coterminal?
Add or subtract 2 pi.
Add or subtract 2 pi. In this case, is my angle too big or too small? Too big, so I should be subtracting 2 pi. Exactly right. Very good. If we make a common denominator, that'll be 12 pi, or 11 pi over 6 minus 12 pi over 6, giving -pi over 6, and that is the answer we're looking for. Notice if I went to my calculator and I was in radian mode, if I do sine inverse of -1/2, I get that decimal, which is the same thing as -pi over 6. Everybody kind of see that? So it's eminently checkable on your calculator, right? You type the thing into your calculator, it's going to give you the kooky decimal, which you can check against the exact value that you found using the unit circle. Right? Is everybody okay with that? Okay. So another way that I could have looked at this is I can use another definition of sine, cosine, and tangent to work this. What is the other definition that I can use? I can use the point on the terminal side of my standard position angle definition. So if I do that, so let's say or so again, same question. We're just going to do it a different way. Either way is fine, right? This was we're finding this value on that interval, right? Just like before, we acknowledged that this is quadrant 4 and quadrant 1. Where is sine negative?
On the left.
Below the y-axis, right? Or below the x-axis, where the y's are negative. So quadrant 3 and quadrant 4. Of those two places, I know I must be in quadrant 4. Everybody's cool with that? For both of those two things to be true, sine to be negative, and it has to be in either quadrant 4 or quadrant 1. Well, sine is negative when the y-coordinate is negative. So that's below the x-axis. So that's quadrant 3 and 4. Is that cool?
Yeah.
Okay. So I know when I draw my picture that the angle that I'm drawing is going to be here. Everybody agree with that? This is equivalent to saying, oh, I'm sorry, I forgot to draw the inverse symbol on there. This is the equivalent of saying sine of theta equals negative 1/2. Everybody agree with that? Sine inverse of negative 1/2 is the same thing as saying sine equals negative 1/2. Right? That's just our definition of an inverse. So remember that this is y over r. So if I make like a right triangle here, r, y, and then I can solve for x. Do I really need to solve for x though? Shouldn't we recognize this as a 30, 60, 90 triangle? If you don't, you can always use the Pythagorean theorem to solve for x, but it's going to be square root 3. If it's an exact value, what kind of angle do you know you're going to be making? It's got to be like a 30, 60, or 45, right? So you got to be getting one of these special right triangles back. So this is a 30, 60, 90 triangle. Since this is the short side, I know that that's the small angle. So that's the 30-degree angle, or if I convert 30 degrees to radians, that's pi over 6. Is everybody okay? And I know that my angle that I'm going to be finding needs to go this direction. So that means that this is equal to, since I'm going backwards, going clockwise on the unit circle, or rotating clockwise, it's going to be negative pi over 6. Everybody's okay with that? either way of doing this is fine. I will tell you, from my perspective, I think the first way of thinking about this is the better way of thinking about it. Because if this is no longer an exact value problem, I think the method we're going to use is going to be more similar. But it's whatever you're comfortable with. Nolan?
So we don't have to like be good with both ways of doing it.
Correct. Yeah, if you can do it one way, you're fine. Okay. Now, I want to note the difference between if we ask you to solve for theta when cosine theta is equal to negative root 2 over 2, and theta, well, let's actually make this between 3 pi and 4 pi. And actually, let's take that off and I'm going to make that just a decimal. My apologies. So here, it tells me where I'm looking for my answer between, right? That's the new interval that I'm looking for it on. It's not going to be the interval it's not going to be the range of cosine inverse, which I need to use to solve this. I'm going to need to adjust that answer, make sure the answer I'm finding for cosine inverse, or from cosine inverse, matches this description. So first thing I'm going to do is recognize that cosine theta equals negative 0.82. It's really the same thing as cosine inverse of negative 0.82, right? That those two are equivalent statements. Now I want to take a moment and figure out what quadrant this angle theta is. Where is that angle theta's terminal side located? What quadrant? Cosine is negative in quadrants 2 and in quadrants 3, right? Because the x coordinates are negative here and here. Everybody agree with that? Cosine is x. So cosine is negative wherever the x coordinate would be negative. What quadrants are covered by the angles from 3 pi to 4 pi? 3 and 4. So if I start here at 0, I go to here, that's 1 pi. I go back here, that's 2 pi. I go to here, that's 3 pi. And then I go to there, it's 4 pi. So the space that I covered there was quadrants 3 and 4. Where is my angle's terminal side located? Quadrant 3. So I'm going to start now by drawing a picture. These are notes, so I want to make sure I'm like really explaining how I'm doing it. Okay? No, you don't have to do all that mumbo jumbo that I just did, but I wanted to talk through how I'm doing it so it doesn't just look like Mr. Kulik looks at this and knows, even though he can look at it and know, right? Because if you can't, the notes would not be very helpful to you, right? Okay, so again, we're starting at 0. We go 1 pi, 2 pi, 3 pi, and then we're ending in quadrant 4 somewhere, right? Does Mr. Kulik care where you put the terminal side in quadrant 4? No, he does not. But this is like our standard position angle. Remember when we spent all that time earlier drawing those standard position angles? Actually, let's just... Everybody's cool with that? With the picture I've drawn here? So that angle that I've drawn, that rotation mark in red, is my angle theta. That's what I need. So what I'm going to find with my calculator is that angle I'm going to call, well, let's just use, yeah, I might as well. I think I use the same symbol in the key. I'm going to use that symbol. That's the Greek letter phi, P-H-I. Like fee, fi, fo, fum. It can all be a giant that's going to grind up the bones of some Englishmen to bake your bread or something. Do that on your own time, though. No bone grinding in class. At least not in this class. I don't know what you do in biology. Maybe that's a thing you do. I don't know. Is everybody okay there? What is the relationship between theta, phi, and then 4 pi, which is the initial side of my angle? Is 4 pi more or less than theta? More, right? Theta has to be between 3 and 4 pi, so clearly theta has to be less than 4 pi. How much less than 4 pi is it? Phi, right? It's just phi less. Everybody agree with that? Yes? Yeah. If I add theta plus phi, we'll just end up at 4 pi. So theta is just going to be 4 pi minus phi. Okay, so far so good. So this problem really just boils down to calculating phi then. If I have phi, I'm going to get everything that I need. You guys agree? Okay. The way that we calculate phi is we're going to do cosine inverse of the absolute value of 0.82. Now notice when I type this into the calculator, I'm not going to bother typing in the absolute value sign. I'm just going to get rid of the negative sign myself. Is everybody okay with that? So that's 11.96-ish. Oops, that was supposed to be an equal sign there. What mode does your calculator need to be in? Radians. Why? We're using pi's in here, right? When we did this stuff, this is all telling you radian, 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 radian. Please be in radians. Here's the lovely piece of this. This process really remains the same with only minor modifications regardless of the problem. whether you're doing a sine, cosine, cosecant, secant, cotangent, whatever, minor modifications, but it's largely the same process. Let me show you another example. Yes? Everybody want to see that? Okay. So let's do another one. What's up? CSC is cosecant. Sorry. No, the first method was contingent on getting an exact value. Notice this is not a unit circle value. It's not like 1/2 or the square root of 2/2 or square root of 3/3. Like, it's not a unit circle value. So automatically, I know I can't use the unit circle to get this. I'm going to have to use a calculator. Does that? And again, usually the directions will say exact value, and that's an indicator then that the unit circle is going to be a necessity. Or a 30, 60, 90, 45, 45, 90 triangle. Have to do one of those two things to get the exact value. All right. So this is the same thing as saying cosecant of theta has to equal 1.57, right? What's the relationship between cosecant and sine, cosine, tangent? Good. Cosecant is the reciprocal of sine. So I can say that, right? Everybody agree? Okay. So then if I flip both sides of my equation, I get that. That's okay still, right? Does everybody agree? And this is equivalent to saying then sine inverse of negative 1/1.57. Why did I bother doing that? Do I have a cosecant inverse button on my calculator? I do not. I do not. So I do need to start by writing it in terms of a sine, cosine, or tangent. Notice though, what did I really do? I just switched it out for the reciprocal function, then did the reciprocal of the inside, right? Now, do you need to do all the work that I did here? No. But if you forget, what do I do again? This is how you can shortcut through that step if you would like. Again, these are notes, I'm trying to be clear. You know what I mean? We're good though? Okay, so now we're back to the same process. I notice that sine is negative. What quadrants is sine negative in? 3 and 4. What quadrants cover negative 5 pi over 2 to negative 3 pi over 2? I would draw a picture here, right? So negative pi over 2 and then we'll go up to negative 3 pi over 2, and then down to negative 5 pi over 2. So we covered then quadrants 1 and 4. Is everybody okay with that?
How much pi is like 4
A quarter? Or I'm sorry, a half
Yes.
is 1 quadrant,
So what is 180?
is a pi.
That's pi. So that's each one the pi.
So again, it's like a half, a half, a half, a half, a half. Right, so this is like 1.5, and this is like 2.5. So I just did like 3 quadrants and then 2 more quadrants. So what this tells me, though, is where to draw my picture. Has to be in quadrant 4. So far, so good? So here's my initial side. I'll draw down into quadrant 4. But when I draw this, I have to go in the reverse direction, right? So negative a half, negative 1, negative 1.5, negative 2, and then to my answer. The piece that I care about is the label on the initial side of my angle, right? So what I care about is this forms, I need that value there. Is everybody okay? So still the same thing we did before. This is my angle. This is my phi. Here's the tricky question. What's the relationship between phi, theta, and negative 2 pi? Is theta bigger or smaller than negative 2 pi? It's bigger because negatives, guys, negatives, right? Negative 2 pi is here. This is more negative, right? It's more negative. Everybody agree with that? So, oops. Instead of adding phi here, we're subtracting. Wait a minute. Is that what I wanted? Yeah. Oh, no. We're adding phi. Hold on. I don't ever write it this way. What do I want to do here? That's the way I like to write it. Everybody okay? Or no?
It's a the negative 2 pi
Well, when I'm drawing, so I'm negative pi over 2, negative 1 pi, negative 1.5 pi, negative 2 pi. That was the last the last part of the x-axis I crossed. So the spiral is theta. That's the angle I'm looking for.
Oh, so we're just.
So if I go theta doesn't get me all the way to, or 2 pi doesn't get me all the way to theta, right? After negative 2 pi, I have to go negative phi more, right? So theta is negative 2 pi minus phi, right? Because from like here to here, that's negative 2 pi, and I gotta go negative phi more. Everybody agree with that to get to theta? And what is phi? Sine inverse of the absolute value, negative 1 over 1.57. So negative 697. Nolan?
Why does in that one part it says theta equals sine inverse of 1 over negative 1 over 1.57, but then E also equals that?
No, phi is the sine inverse of the absolute value, right? Notice that we have the absolute values there. Because this is really, I also really need that extra, you know, like the extra requirement of where theta is, right? Like I really should have this on there too. You know what I mean? Like that still has to come with it really for that statement. So theta's equal to sine inverse of yada, 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 where theta is between these angles. That's what we're finding is that theta between the two angles. Does that?
Yeah.
Yeah, again, clarifying what's going on, I think, really is enormously important here. Because this is a little tricky, right? You guys, how we doing? Do another? Let's do another, right?
Is there like a tangent one?
Absolutely, we can do a tangent one. All right. Of course. First up, let's figure out the quadrant that we're living in. Which quadrant is tangent negative in? Quadrants 2 and 4. Remember, tangent is y over x. So tangent is negative when only one of y or x is negative. So that would be quadrants 2 and quadrants 4. And then what quadrants are covered by 9 pi over 2 to 11 pi over 2? I don't know, Mr. Kulik. Well, let's draw the picture, right? So because these are positive, we're going counterclockwise. So a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. That's where we're starting. 5, 5.5. That's where we're ending. Everybody okay with what I did to count around? Just figuring that out? Is that no big deal? Just some counting. What quadrants do we have there? 2 and 3. So we want our answer in quadrant 2. There's my angle in quadrant 2. Let me draw the rotation marks for my theta. So half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, down to my theta. Everybody's cool with the picture we've drawn here? Notice this one's a little different than the previous two examples, right? Where is phi at? And the x-axis. This is phi this time. So how far was this? 5 pi. Everybody agree? So is theta more than 5 pi or less than 5 pi? Less. How much less? Phi less. Exactly right. So now it's just calculator time. This is starting to feel more comfortable. So 14.31. Just worth pointing out to you that you can check this, right? If I do then tangent of that angle, I better get negative 5.72 back, which I do. And if I check, I want to make sure that this angle, 14.31, is between 9 pi over 2 and 11 pi over 2. So it's bigger than 9 pi over 2. And smaller than 11 pi over 2. So I'm definitely sure that this is correct. Do you guys see what I did there? I just want to make sure that if I plug the angle back in, I get the desired output, and that the angle that I found is between the upper and lower bounds specified, right? Oh, I forgot what the number was. 1430 something, 31, 32, 31. Didn't write it down. I got excited about showing you how to check it. We think one more time? Let's write this one down, give you a minute to work on, and then we'll go through it together.
So you're like, I should understand what you're doing the circle based off of. Like, are you doing it based off of 35%?
Yes.
Why is it clockwise?
So 9 pi over 2 happened here, and 11 pi over 2 happened here. I just need to make sure my angle stops in between them in the correct quadrant. We decided it had to be in, yeah, because these are positive values. the angles are positive, right?
So we don't care that it's negative 5.72.
Does not matter to me one bit after I figure out the quadrant.
Okay.
That's the only time I matters.
Okay.
Okay. Certainly. All right. What haven't we done yet? Nah. Yeah, that's fine. So find the value for cosine theta where cotangent is equal to negative 10.5 and theta is between negative 4 pi and negative 3 pi. Put like 5 minutes on the clock and then we'll go through where we get to. Okay? 1 more minute. Oh, there it is. All right. So I remember that first thing I need to do is get this in terms of sine or cosine or tangent. So the problem that I'm going to be solving is tan inverse of negative 10.5. I remember tangent is negative in quadrants 2 and quadrants 4. If I'm going from negative 3 pi to negative 6 pi, it's negative a half, negative 1, negative 1 and a half, negative 2, negative 2 and a half, negative 3, and then 3 and a half to negative 4. So we're looking at quadrants 2 and quadrant 1. So my answer I'm looking for is in quadrant 2. I'll draw my picture. Initial side, terminal side. So again, negative a half, negative 1, negative 1 and a half, negative 2, negative 2 and a half. And then, oops, sorry, 1 and a half, 1, negative 2, negative 2 and a half, negative 3, and there's my answer. Sorry, I went the wrong way at first. Oh boy. Are we okay so far? So if I look at this, my theta is more negative than 3 pi, than negative 3 pi, correct? Everybody agree with that? So I should be subtracting phi past it, right?
Is theta bigger than, sorry, is theta bigger than?
So theta is more negative than negative 3 pi because it goes past it. But they're negative numbers, so it actually means it's smaller. That's why we're subtracting.
Okay.
I have like B and whatever it's called. I have them the opposite ways. Like why is
So
Just explain.
phi is always between the terminal side and the x-axis
oh
with whatever you're getting. Some people call this a reference angle. Our textbook doesn't explicitly use that term for that. But you could call it that, and I would know what you meant. And at this point, we're all ready to go, right? It's just calculator time here, my dudes. So we'll do tan inverse of the absolute value, negative 1 over 10.5. Giselle, was that what you needed, though?
yeah, that really helps.
Oh, well, good. I should have said it earlier then, huh?
Yeah.
Bad on me. So there's my answer, negative 5.92. I'll point out that tangent of that is going to give me, well, we'll do cotangent of that. Does give me negative 10.5, right? And if I look at negative 3 pi, that's smaller than negative 3 pi, which is good. And it's bigger than negative 4 pi. Right? So I'm positive I've got my answer. Negative 9.52.
So when you do the tangent of the final answer, like negative 9.52, then it should equal the negative 10.5.
I did this, is what I checked with.
1 over, okay.
Right, I did 1 over tan. Because, I mean, I could have done this, but like, I don't know what negative 1 over 10.5 looks like immediately. I'd have to type that in again and check it against that, which I could do, but if I just went back a step.
You just plug it into your calculator really quickly, just to check.
So if I wanted to do, if I did tangent of this, I should be getting negative 1 over 10.5. I don't know, is that negative 1 over 10.5? I guess I'll have to check. Oh, sure is. That's why I chose to do 1 over do 1 over tangent, because that I could just check is negative 10.5 just from looking at it. I have to type something else in. But you could do it that way, that's fine. Sure, sure. Well, I was going to do something more fun here. What if we do
Are these gonna be like ash?
guys, this is way easier than it looks. Well, I'm going to use my unit circle. Tan of 45, I go to my unit circle. Tangent is y over x, right? So root 2 over 2 divided by root 2 over 2. What's that give me?
1.
1. So that's cosine inverse of 1. So I go to my unit circle. Where is the x-coordinate equal to 1? Here at 0, or again at 2 pi, right? Everybody agree? Which one of those is in the range of cosine inverse? 0 is. So that's my answer. Done. Did I actually even do any calculation? Did I have to write anything down? No, it was not so bad, right? That was all right. You're just like two-stepping it through the unit circle, right? That's pretty doable. You guys agree?
I really not pay attention. So after you got the 1,
Mhm.
and you went up to the top.
I went to the unit circle.
Yeah, what did you do like after you got 1?
Well, cosine is x.
Yeah.
So I looked for the places where the x-coordinate was equal to 1,
Okay.
and then found the answer that lay in the range of cosine inverse, which was 0 to pi. And that was 0, was the value. Oh, I forgot to do that too, huh? Oh, this is just needs to make mentioned. So you'll see also used relatively interchangeably, like arc cosine or arc sine or arc tan. That's the same thing as sine inverse, cosine inverse, tangent inverse. Okay? Arc sine, arc cosine, arc tangent, the same thing as sine inverse, cosine inverse, tangent inverse. Okay? Just synonym, they mean the same thing.
So would that like refer to like cosine inverse? Sine?
Yes. Yeah, so this would be like sine of cosine inverse of 2x. All right. So on a problem like this, we work from the inside. So I need to figure out the angle where cosine inverse is 2x, right? This is the same thing as saying cosine theta is equal to 2x. So far, so good? So if I think about that then, I can use this to draw a right triangle. If that's my angle theta, I know cosine is adjacent divided by hypotenuse. So I can then use that to find an expression for the third side in terms of x using the Pythagorean theorem. Now, in these kinds of problems, we're always going to assume that we're just kind of working in the first quadrant. So we can drop the plus or minus and just call that positive. Is everybody okay with what I did there? That's the hard part. From here, it's very easy. Because what I have now is, this is just equal to sine of theta. And there's my theta. Sine is opposite over hypotenuse. And I'm done. So again, you just start with the inside. Use that to build your right triangle, and then we'll just use SOHCAHTOA on the right triangle that we built. That's really easy, right? It's not bad. The hardest thing we do are those middle problems where we're trying to find the value for theta in between a certain interval, right? Those are the trickiest ones. No one. Same thing as an inverse. Arc cosine is just cosine inverse. Just synonyms. We love to have, no one in mathematics wants to give up on their notation that they used growing up. So we have all these different notations that all mean the same thing. This is one of those cases. What do you think? We're done here today. What can you guys do at this point? You can do 1 through 18. And you can do worksheet 1, worksheet 2, worksheet 4. This is not due this weekend, FYI, guys. Come on now. You know Mr. Kulik better than that. Yes. This is due like the 30th or whatever is when this is the due date on this. Worksheet 1 and worksheet 2 will resemble the kinds of things you'll have to do on the homework quiz.
1 and 2?
Yeah, if I were you, that would be the stuff I would certainly want to work through.
Is it going to be on?
Today is Friday. Yeah.
Where's the
Oh, ha! I need to put in the book pages and stuff, don't I? Thank you. Let me do that right click.
That's good.